Good morning. In this video, we are going to see a single block on a inclined plane problem. Now, let us go to the problem. A mass of 50 kg is located on a inclined plane whose coefficient of friction is 0.25. Determine the first condition. The minimum force P to hold the mass from sliding down the plane. Second one, the minimum force P required to push the mass up the plane. Now let us understand the problem very clearly. There is a mass 50 kg which is kept on a inclined plane, and this inclined plane has the coefficient of friction as 0.25. Okay. Now in the first condition, this mass tries to move down, okay, or sliding down. So what is the minimum force needed to stop that motion? Is the first condition. In the second condition, the same mass, but I want to push the mass up. Now what is the minimum force needed to move the mass up the plane? Okay, though it looks similar, but there are some differences that we will see in this problem in detail. Now go to the solution. In the first case, the mass moves down the plane, and I am going to stop this movement with the help of a force P, the minimum force P. Now you see here the friction force helps the force P in the way like when the object moves down, the friction force will act in upward direction or in the direction of applied force. In this way, the friction force helps and supports the applied force P. Now in the second step, let us draw the free body diagram. So here is the mass 50 kg. So there should be a weight. Then the applied force P. You just note that this force P is acting in the horizontal direction. Then there is a normal reaction offered by this surface, which will be always perpendicular to this direction. Then there will be a friction force. Okay, but you see here in the first case, this mass is moving down, so the friction force should be always opposite to the motion, so it will be in the upward direction. So this is very important thing. In this case, the friction force is acting in the upward direction. Now next you just change the coordinate system according to the inclined plane. Now this x-axis is parallel to this inclined plane, and y-axis is just 90 degree to that inclined plane. Now here is the free body diagram. This is the weight, and this is the applied force, and this is the normal reaction, and this is the friction, and please note that it is acting in the upward direction. Now as we saw here, so this is the new coordinates, but among these four forces, these two are parallel to either x-axis and y-axis, but these two forces are neither parallel to x-axis nor parallel to y-axis. So in this situation, you have to go for finding the components, one along x direction and another one along y direction. Now let us go and see. You see here, this is the angle 30 degree, and assume that it is the alpha. And now please note that this alpha is the angle between this vertical axis as well as this weight. Okay, here this is the new y axis, and here is the weight y. So the opposite side, which is nothing but the x component, w sin alpha, and the adjacent side, which is nothing but y component, is w cos alpha. See, in the similar manner, you have to find for the applied force P. Now here is the angle alpha, okay, with respect to the x axis, and here is the opposite side, which is parallel to y axis, and the component is P sin alpha. Here the x component P cos alpha. Okay. Next very important thing, this direction. It should be taken in the correct order. You see here, this force is moving from this end to this end, that is left to right. Accordingly, this component should be marked. It is very important. In the case of weight also like this. Here the weight comes from top to bottom. Similar manner, this direction has to also to be noted, very important thing. Now step 3 is applying the equilibrium equation. Consider this is a particle. So there are two equilibrium equations for particles, summation of f of x equal to 0 and summation of f of y equal to 0. Now apply the first equation, summation of all vertical or y component should be 0. If you take this free body diagram, there are three vertical forces N, and one of the component of weight W cos alpha, and one of the component of force P sin alpha. And among these three, this is positive and these two are negative, okay, because it is acting in this direction and here it is acting in this direction. Now to get the sign conversion, you best refer this diagram, okay. If the force is going in this way, it is positive. Similarly, if the vertical force is going in this way, it is positive, and the remaining two conditions are negative, okay. Now just apply into this equation. Now the equilibrium equation becomes n minus p sin alpha minus w cos alpha equal to 0. From this one you can get the answer for the normal reaction. Now use the next equilibrium equation, which is nothing but summation of all the x component should be 0. Again go to this free body diagram. You see here there are three forces acting in the x direction. One is the friction force, and the one of the component of weight w sin alpha, and one of the component of force P cos alpha. Now among these three, this is the only this force as well as this force are acting in the positive direction of the x, so it is plus. But this force is acting in the opposite direction of plus. If you look at this coordinate, okay, so this force is having a negative sign minus, and apply into this equation. Now P cos alpha plus F minus W sin alpha, which is equal to 0. But we know that friction can be written as mu into N. Now in the place of N, you just substitute this value. So the equation now will become like this. And then exponent, now you just take this F and substitute in this equation. Now this equation will become something like this. And in this equation, you just pick the terms related to P, okay, and just take outside and bring that one in the left hand in the right hand side. Finally this equation will become now like this. This is the equation number 1. Now in this equation you just substitute all this value. W is nothing but 490.5 Newton and alpha is equal to 30. These data are given in the problem, and mu equal to 0.25. Now this equation will become like something like this, and from this equation you can get the answer for P, which is nothing but 140.31 Newton, and the corresponding friction that can be found with the help of this equation, okay, is nothing but 123.73 Newton. Now in the next case, the mass moves up the inclined plane. Please note that here up the inclined plane. So what happens is the friction force will act in opposite direction. That means it will act in the downward direction, okay. But in the earlier first condition, it acts in the upward direction, but in this case it is acting in the downward direction. So it just acts against this applied force. So here it is written friction acts against the applied force P. Now let us go and draw the free body diagram. Now this is the free body diagram similar to the previous condition, but except this force F, the remaining things are same. Now apply the equilibrium equation. The first case is summation of all vertical forces 0. So in this free body diagram there are three vertical forces. One is N and P sin alpha and W cos alpha, and these two forces are acting in the downward, so it is minus, and this is the only force acting upward, so it is plus. So this is the equation, and it becomes like this one, okay, N equal to P sin alpha plus W cos alpha. Now apply the next equation, summation of all horizontal forces 0, and if you look at this case, there are three horizontal forces. One is the friction in the downward direction, so it is minus, and P cos alpha it is plus, and W sin alpha, which is also acting in downward direction, so that is also minus. Now this equation now will become like P cos alpha minus F minus W sin alpha. But we know that friction can be written as mu into N. So in the place of N, you just substitute this value. So this friction will become like this. Now substitute this equation in this one, okay, P in the place of F. So finally this equation will become something like this. And among these four terms, you just pick the term which has the value of p. So this is the one, and just take this remaining term in the right hand side, and finally take the p out. And if you rearrange this equation, you will be getting something like this. Let me take this one as equation number 2. Now substitute these values, W equal to 490.5 Newton and alpha mu into this equation 2. So finally you will get something like this one, and from this one you can get the answer for P, which is nothing but 474.27 Newton. The corresponding value of friction is 165. The Now the answer is the minimum force P needed to stop the mass from sliding is 140.31 Newton. In the second case, the minimum force needed to push the mass up the plane is 474.27 Newton. The reason behind these two differences, you see here, the friction factor will play an important role. In this case, the friction assists to the force P, but in this case, the friction acts against the applied force P. So, because of this reason only, we will have the difference. Moreover, this friction force depends upon the normal reaction, and the normal reaction depends upon two factors. One is the applied force and another one is the weight. So if you look at this equation, P sin alpha, if the alpha is 0, then this term will get cancelled. Okay, in that way normal reaction will be reduced and the friction force will also be reduced. Now let us go when the angle will be 0, when the alpha will be 0. Okay, this is the value of alpha. This value will be 0. Okay, when it becomes 0, you know that this applied force P will act in this direction, so this component will now become 0. Okay, so in order to get the best result, this force should not be applied like this, it should be applied like this, just to parallel to the inclined plane. Okay, you will get the best result. So these are the two things we learned from this problem. Thank you.